Hello everyone, you're welcome to this video. In this video we are going to be looking at 30 multiple questions on isomerism. Okay, so just like we know, to give you a background knowledge, isomerism is a phenomenon whereby two or more organic compounds have the same molecular formula but different structural formula. Okay, and the questions are structured such that each section represents each of the types of isomerism. Now there are 5 major types of isomerism. The first one is chain, the second is positional, okay, the third is functional, then the fourth, based on our level, is geometric, okay, and the fifth is optical, and that is what the whole of this is all about. Now the first 3 are categorized under structural. So the first 3 are structural isomerism, while the other one is called stereoisomerism. So one is structural, the other is stereo. Under structural you have chain, positional, functional, then under stereo you have geometric, optical. So these 30 questions are arranged in such a way that we deal with each of the type of isomerism. I hope that makes sense. Now the first one is chain isomerism, and before we start answering the question, chain isomers simply have different chain lengths. Their chain lengths are different, but they have the same molecular formula. Don't forget that. So look at this question here. It says chain isomers are compounds that have the same molecular formula but difference in A says the position of a functional group along the carbon, B says the nature and position of the functional group, C says the length and the branching of the carbon chain. That is the answer to the question. The length and the branching of the carbon chain is what differentiates chain isomers. Okay, so if I have something like this, let's say I have 1, 2, 3, 4, and this is hydrogen, 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 like this. Then we have hydrogen, hydrogen. The bonds around carbon has to be 4. So we have this hydrogen, hydrogen, hydrogen. Now if you notice, this has 4 carbons and has the number of hydrogen is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means H10. If I want to draw an isomer of this, the length chain would decrease. That means instead of 4, a length of 4, it has to be a length of 3 like this. And while the third one will become a branch this way, you see? So this is a branch. And you can now complete with hydrogens. This is hydrogen, hydrogen, hydrogen to complete the bond 4. This one already has 3 bonds, so we have just one more to make it 4. This one has 1 bond, so we add 3 hydrogens to make it 4. This one has 1 bond, we add 3 hydrogens to make it 4, like this. And one of the ways you know that they are different compounds is that their names are different. For example, this is called butane, or you call it N-butane. It's simply butane, is an alkane. And while this one is called 2-methyl-butane, I would like to refer you to the video I made on naming of organic compound. 30 MCQ questions on organic naming of organic compound. That is very, very helpful. Okay. Yes. So now we move to the second question. The second question says, referring to the diagram above showing C5H12. C5H12 is butane. Pentane. The reason is because 2 times 5 plus 2 will give you 12. And any hydrocarbon that obeys this formula, CnH2n plus 2, is definitely an alkane. An alkane, okay? Very important. Alkene is CnH2n, and alkyne is CnH2n minus 2. I hope you remember that. So referring to the diagram above, C2H5 isomers, which of the following statements is correct? So let's look at it again. If you notice, these are isomers. These are not drawn so well, so You have CH3, CH2, 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 then CH3. This is called N-pentane. It is pentane because you have 1, 2, 3, 4, 5. Okay. Why this one is CH3? This is CH, then CH3, and this is CH2, and this is CH3. Okay, the name of this is N-pentane. The name of this is 2-methylbutane. Now let me say this. Anytime you are given two molecules to compare, one of the first things that should come to your mind is the relationship between them, is that they are isomers. Please don't forget. If you notice, what makes them isomers, even though they have different structures and they are different compounds, but if you count the number of carbons, like here, 1, 2, 3, 4, 5, 5 carbons. Hydrogen, 3 plus 2, 5, 5 plus 2, 7, 7 plus 2, 9, 9 plus 3 is 12. So C5H12. Let's see this. Carbon is 1, 2, 3, 4, 5. Then this one is 3 plus 3, 6, plus 1, 7, plus 2, 9, plus 3, 12. You see, they both have the same molecular formula, but their structures are different. They have different chain lengths. So let's look at the options. It says, referring to the diagram above showing C5H12, which of the following statement is correct? A. N-pentane and 2-methylbutane have the same boiling point. That's not true. They cannot. As a matter of fact, the more branched a chain is, the lower the boiling point it has. You know, that's, by the way, we'll look at that later. Now B says N-pentane and 2-methylpentane have the same molecular formula but different structural formula. That's the answer to that question. Okay, so that leads us to the next one. Okay, now number 3 says, from the structure C4H10 shown in the diagram, how many chain isomers does C4H10 have? Oh, this is interesting. Now, but already it is given here. This is N-butane, 1, 2, 3, 4, and this is 1, 2, 3. This is 2-methylpropane, and we can only see two isomers here, 1, 2, 3, 4, and this one is 1, 2, 3, then a branch. There is no other branch we can do, nothing else, you know. But if it is something like C5H12, let me use this opportunity to do this. And maybe you're in an exam setting and you want to know how many isomers that C5H12 has. You can start with the straight chain, 1, 2, 3, 4, 5. This is C5. If you complete the hydrogens, it's definitely going to be 12. So this is N-pentane. This is pentane. That's the name. Okay. Then I can make it 4 now. The chain length to be 4. Then one of them should be a branch. This will be 2-methylbutane. This is another one. Now I would have shifted this way, but it will still be the same thing. You know, whether this carbon is here, it is 2-methylpentane. Butane, if I move it here, it will still be 2-methylbutane, because here I will have to count from here 1, 2, but if I move it here, I will have to count from here 1, 2. So it's still 2-methylbutane. So that means we are done with only one branch. Let's try 2 branches. So we have 1, 2, 3. That's 3 carbon. Then the other 2 should be a branch. Maybe one should be here and the other one should be here. This is now 2,2-dimethylpropane. That is another isomer, 2,2-dimethylpropane. And from what I can see here, there is no other isomer that this can form. I know somebody might be thinking, okay, why not put one here and put one here to be 1,3-dimethylpropane? But no, that's not true. If you put one here, you put one here, it already means that this is pentane, because the longest chain will now be 1, 2, 3, 4, 5. So that does not work. Don't worry, I know what is going on in your mind. I've been teaching this for years, so I know how students see this. But in the case of C4H10, the answer is B. It has only 2 isomers. But in the case of C5H12, it has 3 isomers. I hope this makes sense. Okay? So that leads us to the 4th one. It says, which pair of compounds are chain isomers? Remember, chain isomers only have different chain lengths. Now, these two cannot be chain isomers. The reason is because they have different functional group. This is an alcohol. This is an ether. So this one is rather a functional isomer. For this one, okay, this one also is functional because this is an aldehyde or alkanal. Watch my previous video to get this. This one is a ketone, so this one is also functional. There are two different functional groups. This one, but 1 in, but 2 in, the same compound, but this is positional. It's just a difference in their position. So the correct answer is B. B is the one that is a chain isomer, because one of them is branch. This one here, if I should write it, is going to be CH3, CH, then CH3 is a branch. Then you now have the CH3, this one. So whenever you have CH3 in a bracket or alkyl group in a bracket, it means it is going to be branch. So you can see that this is just a branch. It's still 1, 2, 3, 4, 4 carbons. 1, 2, 3, 4, 4 carbons. That is one thing I want you to note. Okay, please don't forget this. Now the next one is, it says how many chain isomers exist in the formula C4H614. Oh, this one wants to stress me. Okay, but look at this. I can start with 1, 2, 3, 4, 5, 6. Okay, this is called hexane, or I can call it N-hexane. So let's try 5. 1, 2, 3, 4, 5. Then the remaining one should be a branch. So this is 2-methyl pentane, because it's in position 2, and this is pentane. Now let me move it to this. So this will be 1, 2, 3, 4, 5. But now it is here in this third one. So it becomes 3-methyl pentane. This is also a different compound. Now I'm not putting the hydrogens yet. The reason is because I want to be fast in getting the answer. This is a multiple choice question. If this was a theory question, then I can complete my carbons, my hydrogens. I hope we get that. Okay, so this is 3-methyl pentane. Now it will not be wise to move this here. That's to make it like this. 1, 2, 3, 4, 5. Then move it here. This is not another isomer, because this one is also 2-methyl 1, 2, 3, 4, 5. 2-methyl pentane, which is the same thing as this. The only difference is that here we are counting from the right to make it 2, but here we are counting from the left to make it 2. So we are not going to count this as one of the isomers. But I think we can still make, so we are done with making one branch. Now let's try 2 branches. So we are going to have 4 carbons, 1, 2, 3, 4 now. Then we have 2 as a branch. They can be on the same position, they can be on different position. Let me put 1 here and 1 here to be on the same position. This is going to be 2,2-dimethyl-butane. You see that? 2,2-dimethyl-butane. Then I can still do 1, 2, 3, 4. Then maybe 1 here and 1 here. Okay, so this one here is simply 2,3-dimethyl-butane. Okay, this one is 2,3-dimethyl-butane. This one makes a lot of sense. Okay, so at position 2 and position 3. Are you with me? Now let's see. I want to see if there is a possibility of saying 1, 2, 3, 4, then make ethyl 1, 2. That's, ethyl instead of methyl. You can have ethyl, but this is not going to work. You know why? Because putting this here means that the longest chain is still going to be 1, 2, 3, 4, 5. So this is still 3-methyl pentane, which is already what we have here. So this is off. That means there is no other structure here that represents a structural isomer. So let's count how many we have here. This is 1, this is 2, this is 3, this is 4, this is 5. So the answer is 5. So we have 5 chain isomers. I hope this makes sense. Okay, so that leads us to number 6. Now, number 6 says, which of the following physical property differences is typically observed in chain isomers? Don't forget this. It is boiling point. You don't need to go. So the answer to this question is C. Forget about, is C. Branch chain isomers have lower boiling point than straight chain counterparts due to their reduced surface area. And I think I already mentioned that earlier. Branch chain isomers, their boiling point is usually lower than straight chain isomers. Straight chain isomers have higher boiling point than branch chain isomers. Always know this. So if you want to compare boiling point, let's say you have something like this, CH3, CH2, CH2, CH3, and you want to compare the boiling point with CH3, CH3, then here has a branch CH3. If you notice, they are isomers. They have the same number of carbons, they have the same number of hydrogens, but the difference between the two now is that one is branched. So the boiling point for this is definitely going to be greater than the boiling point for this, because this is branched. The more branched it is, the lower the boiling point. The less the straighter it is, the more the boiling point. I hope that makes sense. Okay, so the next one has to do with positional isomers. Now, let me give a brief history here. Positional isomers have different positions in their functional group. So their positions is different. And it's only possible with those organic compounds that have functional group, like alkenes, like you see in the example here, like alkanols. Let me give an example. Look at this. CH2, CH2, CH2OH. Now, the name of this compound is propan 1-ol because the OH is in position 1. You see, the OH is attached to the first carbon. But if I have something like this, CH3, CH, then OH, then CH3, you see that the OH here is attached to the second carbon. This is called propan 2-ol. This is an example of a positional isomers, just different positions of their functional group. I hope that makes sense. So that leads us to the seventh question here. It says, study the diagram C4H8, that's alkene. This is a butene because 2 times 4 is 8, so that's an alkene. Positional isomers are compounds that A, have different molecular formula but the same structural formula. No. B, have the same molecular formula and the same carbon skeleton but differ in their position of the functional group of multiple bond, which is the correct answer. Okay. Now number 8 says, from the diagram, which isomer C4H8 has the double bond between C2 and C3? Okay, that's from the diagram above. The one that has double bond between C2 and C3, of course, is but2-ene. If you look at it up, look at this here. This is the first carbon, second carbon, third carbon, fourth carbon. So C2, C3, it is but2-ene that has, a double bond between C2, between that. Okay. Now number 9 says, consider the diagram showing 1 bromopropane and 2 bromopropane. Which statement best describes these two compounds? Look at it here. This is 1 bromopropane. If I should, this is BrCH2, CH2, CH3. And why this one is CH3, then CHBr, okay, then CH3. The difference is that Br here is attached to the first carbon, or here Br is attached to the second carbon. So it says, which statement best describes these two compounds? A says they are chain isomers because, no, that's not true. B says they are positional isomers because the bromine atom is at different position of the same propane chain, and that's the correct answer. I hope this is making sense. Now number 10 says, which of the following pairs represents positional isomers? You don't need to go far. The answer is A, propan 1-ol and propan 2-ol. I already gave an example the other time. Propanal, propanone are different functional group. One is an alkanal, the other one is an alkanone. This one, pentane and 2-methylbutane, that is a chain isomerism, just different in chain length. This one, ethanol and methoxymethane, is simply different functional group. Ethanol is a different functional group, which are alcohols. Methoxymethane is a different functional group, which are ethers, or what you call alkoxides. Okay. Now look at this. This one says, how many positional isomers of dibromobenzene exist? Woo! This looks like work. Okay, but it's a benzene. So C6H4. So I'm going to have this. Watch this. This is benzene. Let me put the bromine here and bromine here. This is one of it. This is 1,2-dibromo. Position 1 and 2. I can do this. I can put the bromine here, then put the second bromine here. This one is 1,3-dibromo at position 1 and position 3. Then we can have something like this. Bromine here, and put the bromine here. This is going to be 1, 2, 3, 4. So 1,4-dibromobenzene. Well, I don't think there is any other isomer. I know somebody is going to do this. It's already ringing in somebody's mind. Your hand is scratching you. You're going to do something like this. Now, but if you do this, it's going to be the same thing as this one here, because I'm going to count on the left now. This is still 1, 2, 3. So this is also 1, 3. So it's not different from this one. I hope it makes sense, because in naming of compound, you can count from left to right. You can also count from right to left. So from what we see here, we only have 3 isomers. I hope that makes sense. Okay. So the next one says but 1 ion. This is but 1 ion. 1, 2, 3, 4. But 1 ion. Ion means is a triple bond alkyne, and but 2 ion are examples of positional isomers. There are no two ways about that. I hope this makes sense. I hope it makes sense. You could also have something like okay, probably we are going to see that in the next video. Okay, so thank you very much. I remain your tutor, Mr. Life Changer. Don't forget to like, share, subscribe, invite as many persons as possible to be a part of what is going on here. Thank you very much. See you in my next video.